I assume.
All right, there you go. There you go.
Let's try again.
Hey, welcome everybody. Welcome to have you here. It's been a long time. Thanks for eating the food when offered. So anyways, just grateful to have Greg here. And also Carson and I were talking about some of the things that maybe as we go forward, because we've been doing a lot of interesting stuff over the years. And I want to talk to you as well. And maybe we'd start in August, just definitely in the fall, kind of like a, what would you call it? Like fundamentals, but just kind of go over some basic stuff and just kind of do a series of that. Like, what are some interesting things about QTL that you don't know about? You know, what about config maps? How are you using them with environment variables? And how are you mounting them? And wait a second, when you do, and in fact, I wanted to talk to you about this, is that when you do a temp, file, the amount of that actually you can get OEM'd because that's against your memory. If you fill it up, and sometimes people would go like, "There's nothing wrong with my program." And the answer is, you're right. You just filled up your memory with junk in your temp file. Anyways, that's the thought. Maybe we're gonna maybe do that and see if people would like to volunteer to host that type of thing. As always, we're gonna record this. Greg, you want it during and after? Whatever questions, and then of course afterwards, then we'll get together. But anyways, thank you for being here and take it away.
Excellent. So just quickly, who here is actually already currently using Gateway API? That's about what I expect. Awesome. Okay. Who here is still using Nginx Ingress? Also what I expected. Cool. So we're going to talk today about Gateway API. I've actually given some of this talk in the past. I think it was about 3 years ago. I talked about multi-cluster gateway, which was one of the main reasons to move to that API. This time, we're going to do a little bit more of just like what's happened, how do we get here, what's going on. So that evolution and history part is kind of interesting. Then we're going to dive into what most people would actually find useful from Gateway API, which is just general traffic routing. There is an interesting version of this for mesh. I don't expect very many people are using that or would use that in the near future. It's very early days for that. And then it's even earlier days for using this for AI, but they move so fast, they're going to do loops, laps around everybody in the very near future. So we're going to try to cover all that. There's a couple demos as well. Should have plenty of time for it. If you do have questions, just stop, let me know. Happy to jump in, whatever. So kind of like quick history. Ingress as V1 Beta 1 for defining Ingress controllers, getting traffic into your Kubernetes clusters, 1.1 Kubernetes resource, right? So it's been around since like 2015. Adoption definitely flourished, right? Like it's a very common use case of I need to get traffic into my cluster. How can I do that? Oh, there's this thing called Ingress. We'll use that. Every cloud provider has their own version of this. Nginx still by far is like one of the most popular ones. It has actually one of the most featureful sets. I quite often get questions from customers being like, "Oh, we use this feature on Nginx. How can we do that somewhere else?" I'm like, actually, no one else uses that.
So they didn't call it Kubernetes in 2015, right? You called it something else?
Yeah, it's the actual names of.
And then later it was Kubernetes.
Yeah, so names definitely changed, but I think on a 1.1 or definitely like by 2018 timeframe, like a lot of this has actually stagnated, right? So those Ingress resources were V1 Beta 1 all the way up until 2021, where they finally 5 years later, right, said we're going to make this a V1 non-beta. And luckily, when they did that, they actually tried going forward. They said like we probably shouldn't do that again. We probably shouldn't have core features of Kubernetes that stay in beta for 5+ years. It is V1 now, it's stable, it's great, but it's also kind of not getting a lot of attention, the Ingress resources. If you were looking for V2 of Ingress, that is Gateway API. Gateway API is a more expressive way of doing all of those things and hopefully a more compatible way across all the providers. I don't know if you've ever tried taking your Nginx Ingress and going to Contour or going to name your favorite Ingress provider. It's not fun or easy. There are custom annotations everywhere, like just super painful. Gateway API 2022, so it's got some history. Didn't really take off at the very beginning because no one wants to go and make a whole bunch of changes. But as new systems come online, new things are created and released. Today, Gateway API is on what they call 1.3, so they're on their third minor release. It has what they call the Gamma initiative, so trying to address mesh workloads. And then this inference extension is something that, AI has a very specific use case for routing traffic. And they said, well, let's see how we can make this work in Gateway. There's a whole separate working group for inference extension in particular. And we'll talk about what they're up to, but they're off running to the races, and, kind of like history repeats itself. We're going through these loops faster and faster as Kubernetes sort of slows down and becomes boring, stable infrastructure. Gateway API is also approaching boring, stable for common use cases and for routing. Mesh, Wild West still, they're still figuring that out. And inference, super Wild West, like they're super crazy stuff. But also, what do I mean by gateway? This is a super fun conversation to have. Is I could name at least 4, probably even more. Gateway API is an upstream open source spec, community driven, just like Kubernetes itself, right? It's the actual definition of what does it mean with this manifest or these, when I say this value, what does that actually mean? Hopefully as specific as possible. It did the actual spec itself, went GA in 2023. So that's the point where they're saying, hey, we think this is good enough, people can start using it. They know changes are going to come. So they have had that 1.1 and 1.2 released last year. 1.3 was I believe, April of this year. We're expecting a 1.4. So they're kind of a 2 release per year cycle. That is the upstream. So people actually implementing that, and even Google, who is in those working groups helping to implement those standards, we don't always launch day 0, right? Quite often we'll lag, just like GKE lags between upstream releases and GKE releases. You kind of have to say like, oh, well, we've standardized this now. Let's do the work to actually implement it. GKE Gateway is Google's implementation of Gateway API, right? Many other providers as well, pretty much every cloud provider, every load balancer, F5, they have, I think, multiple implementations of Gateway API because they have owned multiple load balancing products, portfolio of products. And this is kind of the modern way to actually program those things.
Specification dictated by Google, or is it by a committee?
It's the same community-driven effort. So
like ECMAScript, like the standard? Or?
No, so at the working group, Gateway API is an official Kubernetes project, meaning the same governance across Kubernetes and all of the people involved in that basically have formed working groups. A lot of players from industry, Google's there, representatives from other cloud providers, representatives from Nginx and F5s, and people that just have stakes in it and want to make sure it's done well. But it's very much community driven, just like nobody steers Kubernetes entirely. You can always take it, say like, oh, well, we have this feature we want to do. Let's make sure this works for our feature. We're going to have an implementation over here. But the actual specification itself, it's probably not quite as far as what an ECMAScript or a language compiler has to get to. But it's a community driven effort through working groups and SIGs and all that fun stuff. The worst part about this is there's a very common thing called API gateways. That kind of just means something that sits in a cluster and does composition of microservices. It's kind of how you say, like, I'm going to take these 10 things in the cluster, compose it as one endpoint that people can talk to. You don't need to know or care how that works. It's just an API gateway. There are a lot of products that excel at this. So Kong, Ambassador, Apache has at least one, Glue, and various other things. A lot of them have gateway API methods of programming them. But if I say API gateway, it's like, oh, well, that thing that's composing stuff for you, not the spec or the implementation of the spec. Super fun. And then Istio gateway. A lot of these things did actually get their start in Istio. So if you look at gateway API, if you're familiar with virtual services and various destination rule style stuff, it luckily doesn't look as bad as the Istio APIs. They are notoriously bad at having alphas and betas perpetually still. But that's kind of where things started. Gamma is definitely very much in their space. They're trying to figure out how would this work for Istio, but not just Istio, Linkerd and Kuma and various other mesh providers. And then you could have a gateway API or an Ingress or a service type load balancer or some other means of funneling traffic into either of those. And that's just kind of like the packet routing, right? So those are 3 or 4 different terms, and I'll often try to use the most descriptive version of, if I can. If I'm talking about Istio, I would say Istio Ingress Gateway. That is literally a deployment of YAML you can go and look up. Whereas if I say API gateways, what does that even mean? hopefully just a concept that at least anchors on something. So Ingress, tried and true. Everyone should, see this and somewhat recognize it as, yeah, I have a host name, I have some paths, I can do some, some routing, fairly basic things. Everything more advanced than this ends up being custom annotations. And so this is the minified version of it. If you want to do TLS certificates, you want to do something more advanced, Nginx will have one way of doing it, GCE Ingress would have another way of doing it, and it gets pretty dirty pretty quick. It has been stable now for a little while, which is nice. Google's version of this, so the Ingress GCE controller is the thing that will take Ingress resources tagged with class annotation GCE or GCE internal and turn those into real load balancers, right? Fun fact, they actually did standardize on having this spec Ingress class name. That was after we'd already feature frozen our controller. Our controller does not have Ingress class name as a support. It, I believe, only still allows the annotation. So that's one major difference between like, oh, I want to take this and I'll just use a different class. Well, you can't use, you have to use a class annotation. For Google, you'd have to use Ingress class, or usually they'll just support both because it's a very sloppy spec to be frank. Because that's standardizing like 118 as their preferred way going forward. And by that time, we have already realized it's probably better to just kind of move on. Limitations. Well, everything's a custom extension. Nothing's portable. Simple things like traffic spitting. You just want weighted, canary. Yes, you can do that in a lot of ingresses. None of them do it the same way. Header matching, very common thing, or header additions, or just manipulating headers. Sticky sessions, all these things that are like super common. Everyone ends up needing to use these features at some point, and it's great you can do that in Ingress. And I'm not saying you have to change. If you found a way to do it in Ingress, great. But the idea of being able to do this in a common way with a common set of tools is super nice. And then a big thing that you really can't solve easily in Ingress is shared tenancy. So what does that mean? Well, you got a bunch of services and you want to have them exposed. You'll end up having a lot of ingresses that create a lot of load balancers. So two different service providers, they'll have the front ends and then internally go to back ends, everything's fine there. But from your security team standpoint, now you're just poking holes all over the place. There's no like central control over any of this, and that kind of shared tendency of why can't we just have an F5 where everything goes through the F5 and we get all our policies there and the central point of control? Well, because Ingress just quite frankly doesn't have what it needs to be able to do that. So Gateway API said, what if we actually take a step back, look at what we need, separate out the different roles into different parts. So you have a gateway class where something like Google will implement gateway classes for you. Your infrastructure provider says what classes you have in a managed Kubernetes. You can still build your own. It's not like you're locked out, but that's their job, an infrastructure provider's job to build and implement the classes. Platform administrator, maybe you do have a team managing your clusters. They're the ones that will say like, hey, we'll help you get access into your clusters through defining the gateway resources. And then all your service teams can do their HTTP routes and they're maintaining their services and their namespace, get cross namespace stuff here. But all that kind of separation of control really does go a very long way at being able to make these much easier to use. Some features that Gateway does have inside the spec, meaning if you're a full compliant implementation of v1.3 of Gateway API, some of these things are the header matching, method matching, query parameter, cross namespace routes, cross namespace forwarding. Filters are just ways of doing, manipulating headers, manipulating the request, like just mirroring it. I want to take this request, I'm going to send it to a backend, but also send a copy over here. Maybe you'll find use of that. And a lot of these aren't always mandatory requirements for the core specification, but request mirroring, there's one way to do that in Gateway API. Probably some variants of that one way, but there's at least one core section of how you would configure that. It's really nice. URL rewrites, weighted splitting. If you've ever managed load balancers, you've probably done at least half, if not all of these features. And now it's awesome that they're just a first class feature. It is also designed to be expansive. Like we know there's going to be things in the future that we didn't think about in the past. So core APIs is the set of like to be a compliant 1.3 gateway provider, you have to have this. Everybody has this. If you don't have this, we're going to label you non-compliant, just like there's non-compliant Kubernetes clusters. Doesn't mean it's wrong. It just means, hey, your vendor may not support you if you can't say that you're running on a system that at least tried to check all the boxes to meet some level of compliance. Then there's this extended set where like, we know a lot of people will want to do this, but not everybody. It doesn't make sense in all cases. So we'll just put this in like optional, extended, but still in 100% portable if supported. And then there's full custom of like, we got Cloud Armor. No one else is going to need Cloud Armor style resources on their gateways. They might have some equivalent of WAF. How they do WAF, how we do WAF, probably going to be tough, but we'll leave room for custom extensions, hopefully still all within this umbrella frame. We're also going to do tiering. So we mentioned having all these different levels. Well, Google might have certain default policies that will apply to the gateway level. The platform or your platform team may have it. So we might apply it on a gateway class. The platform team might apply it on a gateway, HTTP route. Service owners can apply something, and then even at the service level. So these policy attachments are what you will see a lot of custom features in Gateway API. Yeah.
Your materializing is down to the bottom. Is that defaulting from the top down, or is it enforced from the top down?
There are versions of both,
Okay.
but more often than not, a lower level will override. It isn't something that's always the most specific, but like if it's the same value, so drain timeout, if I specify something at a higher level and someone specifies something lower, it probably makes more sense that I should use the lower value. So that'll usually be, it overrides it. In this case, you can see what's 10, 10, 60, 60, and a cookie. I guess it did show an override, but my understanding is implementation is currently, if you specify at a lower level, that takes higher precedence than specified at a higher level, unless it's this special kind of policy of like, oh, we're going to make sure it's always like this. Sometimes there's mechanisms to do that. More often than not, that mechanism is like, we're just going to deny admission controllers on everything that would violate that policy.
Is it the controller's job to make those choices? So something that's reading Gateway API and taking in 3 different documents here to try to figure out the effective policy on the final thing, that the controller is the one that there's no standardized logic
I
there.
believe it is, yes. Which is where you could, definitely plenty of areas still for variance on implementation, but luckily there is conformance testing. People are actually building conformance testing suites. And so if they thought that was going to be a problem, the more difficult thing of this is most service policies are almost always completely custom, right? There are certain versions of these that are uniform. More often than not, it's like, we're going to have to change half those values. We're going to make something that looks like an extended API, but we'll pull it into the custom side instead because we're just going to, it makes more sense to be a custom policy, in which case it's only this controller that has to ever manage it. And you can live more. Gateway classes, I think I counted and there's 13 in GKE. 4 of them, I can't even necessarily really tell you what they do. They aren't actual Ingress controllers. There's something that we built for like telcos. They do weird things, but it made sense for them to use Gateway to do it. The more common things are like your regional, your globals, your internals, your externals, maybe a multi-cluster variant. So we have -MCs in GKE, which is just, hey, there's a regional internal gateway, and then there's a regional internal multi-cluster gateway. There's now cross-regional gateways. A lot of this is just Google being Google, but you'll likely see multiple types of classes. I tried Envoy proxy, Envoy gateway implementation of this. You define the gateway class on that. Like this is so DIY. They're like, hey, give it whatever name you want, and so it's a very interesting approach. You may not know, but so Google has had what they call their classical load balancer for a very long time. Tried and true, run google.com forever. We have actually been migrating a lot of ours to just Envoy load balancer. So anytime it says managed on Google, that's referring to a managed instance of Envoy, which is kind of cool. It means that at the end of the day, there's some Envoy config way deep in the guts of somewhere. And if you know that like, oh, well, we want to implement this feature inside an Envoy config, or like, hey, we have an Envoy filter that does this in a service mesh, how would this work somewhere else? You're using the same stack, which is kind of amazing sometimes. And as I mentioned, GC is feature frozen. So like that cross-regional external load balancer, you're not going to get in an Ingress resource. You would only ever be able to get it via a gateway class or a more bespoke like DIY solution to it.
So like if you're just doing one, if I wanted to go make one, am I choosing?
You want an external IP or internal IP?
Internal.
then you're looking for the ones that say external. The only difference between global and regional is global usually means, for us, it means anycast. You're gonna hear from Salt Lake, get terminated at our closest point of presence, which is somewhere in Salt Lake, and then backhaul to wherever your cluster is. And so you kind of get like half a CDN with it, which is cool. Oh, I think I dropped off the internet. Let's see if that.
Is that what an old school Ingress load balancer generated is doing anyway?
So Ingress has the same where you could specify internal or external still. Right? It just doesn't have all of the flavors, right? And it will never get, like, I think the two that it uses right now are closest to, so it doesn't have multi-clusters. It has a global external and a regional internal. So it's these, I think it's the classics. I don't think that they even have the managed envoys, but I would literally have to create an Ingress resource and then go look inside the console to see what it says through a Google API and then match it, because these matrices get crazy. I actually know this line is also wrong. The CRD version, it says we're on 1.1, and that's possibly true on 130, but I can't even create a 130 cluster anymore because that's old. So I think those are up to like 1.2, and we definitely lag currently on our CRDs, which is, there's that kind of CRD hell. Since you can only install one of them, like I want to install here in GKE, like as soon as you turn the feature on, like, no, we're going to manage these because we need these versions. Now you try to install something from upstream and it's like, oh, you got to wait a little bit longer until you'll get that CRD. It used to be this launch stage was important. Like they do launch these in preview. Luckily they're all GA now. I think even cross-regional went straight GA. Different capabilities of, you know, auto scaling based off of the traffic. So like request rate auto scaling, that's a cool feature. Well, you get that in half the load balancers. Multi-cluster splitting, all that fun stuff. Tons of links here. If you find any of this interesting, these I end up pulling these up all the time because I definitely don't have them memorized.
How much do you have to break out into those outer tiers of API layers for this, right? Because you have this like the core, and then you got further and further to the crazy. Like about how much to the crazy? Like if someone were to commit pretty hard and try to use Google as the provider for the gateway, would they be really locking themselves in with a lot of very, very special stuff? Like
so right now we only have L7 load balancers. There is L4 versions of this. So HP route is an L7 application load balancer. TCP route or TLS route is an L4 version of this, meaning you get a network load balancer. We do not currently have network load balancers via gateway API. We only have network load balancers via service type load balancer.
okay.
So MTLS and like things where you really need to make sure termination of stuff is happening in the cluster, you're probably still going to be on an L4 network load balancer, but service type load balancer for now. But in terms of how much stuff can you do and like maybe shift between implementations, that is what we have next year. So I can show there's nothing up my sleeves other than a load balancer for the second or third part of this, so that the VLLM stuff would have taken way too long to set up on the fly. But that's the only gateway that I have right now here.
Doing the light down.
Sorry, I don't know where that one. Anyways, if you can see it, then it's.
Lights are just below you.
Oh,
I don't know. I just press the button until things get dark. There you go.
Yeah, too zealous. So this is our console that shows load balancers. I have one that we'll talk about later. Let's go and just build one, right? So we're going to build this one. And in fact, I will just grab it out of here. Okay, JCLB. Do I need to put this in namespace or no? I didn't. So I'm going to apply this. If you're familiar with our load balancers at all, you may know sometimes they take a little while to actually get programmed. So we're going to start.
Isn't that another thing that improved with gateways? Is like, it seems like messing around with the gateway, it takes much less time to actually change the load balancer, whereas like Ingress, 15-20 minutes was not unusual.
It really depends on who's doing the controller, like.
And I actually, in my opinion, is it's actually not the controllers that are slow. It's the, hey, we're running a global control plane for you. And it's your lab director that is often the long leg. It also then depends, how does it roll it out? Because on a global load balancer, this thing's going global. Literally packets all over the world at what certain points in time, and how are they going to land. So there are certain regions that if you luck out and you're in the region that things go first, it sounds or seems fast to you. Then your coworker on the other side of the US is like, oh, this takes so long. It's like, well, speed of light, but it's more just the propagation of global control planes is a hard thing, and we take our time when things are hard. You will see, so this is running right now. I could either go 2 paths right now. I could literally go and take the same thing and run it on an in-cluster one, and it will finish like 3 minutes before the other one. But we'll start talking through this to show you like the different features. I would expect, I think it took like 2 minutes for it to even show up here. Yeah, so you can see here, waiting to be accepted. It saw an object. The controller probably hasn't picked it up, or if it has, it hasn't gone through enough of the creation process to actually go to the next phase of this. But let's just see what this thing's going to do. So we have a shared namespace. We have a gateway resource with a class. So this is a global external managed instance of Envoy. It is going to be pinned to a host name here. It's only using HTTP. I have another one. Actually, the second one has TLS. So if you care about that, see that. I did use a static IP address. It makes it easier because there's a DNS entry here. So like I can just link it up to a static address. There's 2 ways of doing that. Apparently this one is deprecated. I just learned that. I don't know why. They're switching to something else. So definitely still some, some learning curve, some pain as they iron these out. You can also just specify an IP on it instead. But now they're moving to some like prefix version. Sure, there's a reason for those. We're attaching an HTTP route to that parent ref gateway in a different, well, so these are in the same, but depending how you configure these, right? So I said namespace all. So let anything connect to this gateway. There's actually an opposite of like, well, can I, if there was an HTTP route somewhere else, is there permission or a service grant? Like they call it a reference grant, but you kind of have to do permissioning on both sides because that makes sense.
That parent refs almost basically takes the place of the more flexible, more official version of Ingress class. Right?
Correct. So
like singular, so you couldn't say like have it this registered in 2. You have to like duplicate the thing. But it's the same idea. It's like you're targeting saying this config is for that thing.
Because Ingress didn't have the ability to do any sharing. So like gateway class is the direct comparison to Ingress class. It says what kind of a load balancer, but then you're like, I want this specific instance and I'm going to reference that specific instance. So the gateway is where you actually have a listener and like you do port bindings, you do TLS stuff on the gateway. HTTP routes are just all stuff. You're going to have a bunch of these routes, right? Like you can have a whole bunch of HTTP routes all attached to the same gateway. They do the same, like most preferred length, most match, I believe. So some might be a wild card, but then if I have an explicit one, that will.
What intrigues me about that is the parent refs is multiple. Sorry, that's the thing is
Correct.
you can make 6 gateways.
I don't think I have seen more than one in here.
Yeah.
But they were smart enough to say like, we might want that in the future. Why not make it a list versus?
Literally wrote an entire controller to duplicate Ingress things live all the time because that didn't exist in Ingress. So
It was pretty
Like I said, we've stepped on all the rigs.
yeah, no, that's great. That's a small thing, but a big deal for those that have needed it.
I think 2 is somewhat common because you can have, if you want HTTP and HTTPS, you just do 2 parent refs to the same gateway.
Correct. And I don't have it on this one, but we'll see on the other one. You can actually even specify the protocol or the schema that you're binding to on the parent ref. So you could have routes that say, I'm going to bind this to the HTTP side of this shared gateway, and I'm going to bind this to the HTTP. So like the HTTP side maybe just does a redirect to the HTTPS side. Matches. So there's going to be a whole bunch of these matches. The first one here says, I'm going to take the docs route and forward it somewhere else. I'm just going to generate a 302. This is what generating a 302 looks like. There's things you can do where instead of replacing the full path, you can replace a prefix, but that is common for redirects. Pinning to a specific service. So if I see this path prefix, I'm going to pin to this service in this namespace. If I see, it's also because that service doesn't like having a prefix when requests land on it, I'm going to strip that prefix. So the request that actually lands downstream has the path of just the other stuff, not the prefix. If you've ever tried doing proxying, that's important. Same thing for a second version of that. So just a second namespace with a second stripping of the prefix. Weighted. So we're going to do a canary here. If you go to /canary, it's 80-20, 80% to the old version, 20% to the new version. We still need to strip the prefix. So that's a weighted traffic split there. But we're also going to do some header manipulation here. So this is a filter. One filter is a rewrite. One filter is just modifying headers on the request to the downstream or upstream. I always get those confused. I'm going to put a is canary header on there. And then our load balancers have fancy variables you can cram in there. So client region, city, lat long. We're going to shove that in a header. The backend service can now use that information because it was just generated on the global load balancer.
That's an example where it's like just a little bit of like, well, if you use this, it won't translate one-to-one over somebody else. But
I had to find something
no,
that's
it's great.
and then a default route. So if it doesn't work, we're just going to land on this here. So if I stalled long enough.
Sorry, one more question. We'll help you stall it more. I couldn't help notice you were showing an example. It's like, here's a host, here's all of the paths in a single resource. I assume it's fine if you were to compose like 10 of each of these like rules sections was just its own resource and they all share the same host.
So the most common way of doing it is like you're going to have a wildcard listener start on something and you're going to attach routes for specific host names and you'll probably do most of your paths all within one HTTP route. If you start trying to combine those two, the way, and so they're not ordered, there's no like first instance of HTTP route, second instance of HTTP route. It matches host name on most specific. If you have multiple matches on a host name, I don't know if that's not valid. If you can do that composition, right? Like this is kind of
right now, right?
in Nginx terms, this is the virtual server, right?
Yeah.
And you kind of need as much of that information all in there. But you can split them up and you can definitely attach as many HTTP routes as you want with as many host names as you want onto the same gateway.
Is there a precedence as far as is there ordering of those at all? And if there is,
So just there's never ordering in Kubernetes resources, right? Unless you're presented a list, and even that list isn't always guaranteed to be ordered.
so with inside there's no order as far as when it will evaluate first.
So ordered within a single resource, it looked like it was
Yeah.
ordered.
So within the rules, it is top down.
It's up down.
So
Outside it's all bets off.
and that's usually how lists work inside Kubernetes.
Right.
Inside an object, they're ordered, but when you're talking about stuff outside that, it's usually not. So this is just a little silly thing here. See, somebody really likes tabs. So let's try some of those routes. So we had an app one. Hey, look at that. Unfortunately, this just spits it out in a whole bunch of JSON. I do happen to know if I were to request this with a value, so pod namespace, right? And so this is just pulling out pod namespace. It wouldn't work if I tried to curl it with app one, but we did strip that prefix. So now this works. So I can just keep it right here, and it's always going to land on app one. If I went to the canary instead, so canary. And this should be, 80-20. You can see some ones, some twos, some ones, some twos. And if I go to just headers, you can see those headers.
You basically use the path routing to get to
Yeah, this is just, so I'm just exercising all those paths we created to see that they all work. You do see our is true. You can see it also canonicalized them. Our load balancers canonicalize header names. So And this is what the backend, so this is an echo server, right? It's just echoing back what was sent to it. So we can see it sent that, it sent, we're in Provo and at this that long. That's kind of cool. I don't think there was anything else really in there. So that was an entire load balancer. Here we do see those reference grants. So because this other namespace, if I didn't include this reference grant, the shared gateway in the shared gateway namespace couldn't access the service in the other. Like that's not an implicit permission thing, just like you can't reference secrets in another namespace. So this is saying any HP routes in the shared gateway namespace can access all services in this namespace. And I have two of this.
Oh, interesting. Yeah, because that was completely not like your Ingress just had to live in the same namespace as the thing you're
Yeah,
routing.
that was impossible in Ingress.
Yeah.
So, yeah.
So basically, like, even though we define at the beginning that all namespace can access the API gateway, we have to give individual.
Yeah, that would be if you wanted the HP route to live with the application, which sometimes makes sense. In this case, I wanted to show the reference grant, and so I had to have the HP route live in the shared gateway namespace. Maybe you have a networking team, it's their job to manage the routes.
Well, it's two different directions, right? So the thing in the gateway says this route can reach up to point at these gateways. The reference is when a route wants to reach across namespaces to point to a service inside somebody else's namespace that has to have been allowed, right? In the past, you just, like I said, in Ingress, you couldn't. In Ingress, you're like, I'm making an Ingress here and I want this path to go to this service in a different namespace. There's literally no field in the Ingress spec to say where you just give it service name, you can't change namespace. So it's two different kinds. One's the top first one we saw was the lateral grant, or upward grant, the other one was lateral.
Oh, no, never mind.
Okay, thank you.
Yeah.
On so if you go back to the headers, so the text forwarded for. So the first one of those is the managed.
Yeah, it's whatever the normal. It's the same load balancer. So at the end of the day, this is this exact same load balancer you would get with an Ingress resource. There's no difference in terms of data plane inside of Google Cloud. It's just, it was created, so you can create them using what we would call Google APIs. So G Cloud commands to create load balancers. You can create them with Ingress resources, or you can create them with resources. The only difference is what controller is calling what. At the end of the day, everything has to make a call to a Google Cloud API. Like that's the way you create these. But was it done by an Ingress GCE or was it done by GKE Gateway controller?
But like in the inbound route, when you were echoing out the headers on your example, right?
So like this is my public IP, and this is probably the load balancer IP.
Is that like I'm running a dedicated Envoy, or is it just hitting some?
It is, so that IP address is only for you,
Right.
and your gateway and the routes that you program for it. It's the easiest way to phrase it. But it's an anycast IP, right? So like that address, I send packets to it and they end up in Salt Lake City. If you're in Florida, they'll end up somewhere else because it's just going to land on the POP. So I do have, these are the four that I really can't even tell you what they're doing. But there's this EG, which is the Envoy gateway. Wonder what it would take to take all of those same features and run them on Envoy. Well,
This is EG you speak of.
Yeah, are you looking at a different thing?
You're only streaming your browser. Might be by design, I don't know.
representing, show my screen anyways. Say that. Something. Screen. This. Oop, there, that one. So if
Will make sense now.
this. Features 2 a.m. So I'm going to apply the second one And the only differences are I'm going to add a 2 to a bunch of these names. I'm going to change the class. I could not figure out, having just tried to use this yesterday, I've never used Envoy Gateway before. I could not figure out how to make it use my as an assigned static address. It should have the ability as to, if it definitely doesn't like my named address. It probably, because this is actually fronted by an NLB, I probably need to make sure it gets it into the annotation spot of the NLB. That's my guess. I'm going to add some more 2s. I'm going to give it gateway 2. Everything else is exactly the same, right?
Yeah, I don't think your header,
So the header, it'll still take the custom header.
it's just gonna point it out the placeholders as literal. Okay.
So
This is like open source, like upstream Envoy Gateway, not.
if you were doing on-prem with Metal LB as your L4 provider for on-prem, this would probably be one of your preferred gateway classes, along with Kong and others that are going to play well in that. Apply stuff. Just find the second one. Something I learned that I didn't even know is that'll show up here too. It's not even our gateway resource. How about it shows up there? Oh, of course it didn't. Oh, no address. So that's actually fine. That's what theirs looks like when it's being provisioned. Give it a little bit longer. I would expect it to actually come up. The fun part about this is, so if you've done stuff in Kubernetes, like now to troubleshoot this, like you need to be watching events on routes and gateways, and like there's a whole bunch of controllers involved here. So actually finding those, I'm glad that they started building out these tools. Unfortunately, this tool doesn't even have everything. There's a whole nother here. Gateway service network. What's this? Yeah, I can't even find these things. Open up this one. This one shows you from like a GCP perspective all of the resources. It just doesn't have the Kubernetes view of how they get linked. So this one is what it just created. Doesn't seem to like it. Yeah, this worked yesterday when I tried it. Has all its backends. Oh, no, there we go. Program. Because it didn't give me the address, I do need to. DNS. I just have to manually update the IP, and then that entire stack should still work. The only thing that doesn't is it literally just prints that echo header. There, save it. Turn space apparently. As long as the browser didn't cache this, this should show forwarding to the exact same sites. And the only actually interesting thing is Canary headers. It of course does not understand because there's nothing in front of it to do injection of variables. So everything else just worked exactly the same. There are definitely things that don't. So as soon as you get into policy attachments, you would not expect that. Even so much as just a health check.
That's still a lot of stuff. That's a ton of stuff. Compared to Ingress paths.
Yeah. And like,
Okay.
I mean, that's 100 lines of Nginx config.
Yeah.
Easily. But scenes it goes across. All right.
100 lines of Nginx you'll get wrong 100 times. before you
And
get
we'll
right.
break on every version change.
Yeah.
All of that. So
It's not in Lua, is that what you said?
well, so that's the reason why Nginx wins is I will show you, and we may or may not have a ton of time for it, but I'll show you the thing that actually, in my mind, can possibly replace Lua, because up until then, Walmart was using Lua, right? Like big companies that need to do super crazy Ingress things, they either build their own proxy servers or they implemented Lua, and that's kind of crazy pants. So, only slide I have on Gamma. The service mesh people saw this and was like, hey, that's awesome. How can we make that work for Service Mesh? Well, the problem is Service Mesh makes everything 10 times more complicated. They have rules on everything and nobody really implemented the same. So this is still being worked out. Istio does see it as their future. They currently you can program Istio using Istio APIs. They call them legacy APIs, straight up, which I thought was interesting. Or you can use Gateway API. The things you can do in Gateway API are like 50% of what you can do in Istio APIs. So they have a lot to get there. I've been working with some people that are trying to do advanced MTLS stuff. Does not exist in Gateway API. Like you can do TLS termination, you can do a bunch of search stuff. When it comes to like very advanced MTLS like authorization, it just isn't in the API yet. But I hear it's coming. So hopefully that'll happen in the future. If you ever saw Tim Hawkins' talk in 2023, where he was talking about the service resource and how that is just a kitchen sink full of everything, right? It is one of the most overloaded APIs in Kubernetes. This is how they're potentially going to try to solve that, is they'll say, hey, you know, even those services you're using everywhere, like at some point, maybe you'll be pointing at gateways instead, but they're having to do this, like, how do we break it into like a front end part of the service and the back end? So the major change here, those things that we were referencing, parent ref, instead of parent ref gateway, parent ref service. That's how they're doing it currently. And it's expansive enough that it just works. I do not have a demo for it. If you were at KubeCon, they actually had someone from Buoyant for Linkerd and someone from Microsoft for Istio. When did the exact same thing. They spent the whole hour on it, showing some pretty interesting things. If you're using what I would actually call rudimentary service mesh features, like they're definitely not the in-depth thing, but it still lets you get a very far down that path without having to worry as much about what happens if I ever need to change this. So worth watching that demo if you Gateway API, we'll spend a little bit of time here. So this is, in my opinion, the Gateway API project is probably one of the better SIGs and like has produced a fairly significant output from that kind of community driven process. It has been insane how fast the AI teams have latched on, being like, I think they literally copied the SIG's website, pasted it, and then just started writing stuff. And they're at version 0.4. I know that because I was making a demo for this on 0.3, and they released it over the weekend, and I had to go and make a whole bunch of updates. So that was super fun. It is very, very early days. They call it alpha. I believe them. It is still working through a ton of stuff, but definitely gaining momentum. Inference, if you're not familiar, they have very specific things that they care about, like the cache fill ratio of the GPU you're landing on. No microservice router ever cared about caches inside chips of the computer you were landing on. That was never a concept that they cared about, but GPUs are, that's apparently a very important thing, definitely way above my head how all that works. And so they tried to find ways of making it work in Gateway API. For this, again, they've replaced parts. So now instead of pointing to a gateway, they said, well, what if we do, or so they don't replace the gateway. They actually use the same gateway classes and the same like core, what I would call data plane. So all of that is GA. Yay, I like that. I hate untested data planes. Those are just rife with errors. But instead of pointing to services, you point to backends of what they call inference pools, which is just a deployment of some inferencing server. The two supported right now are VLLM or Triton, two very popular ones, but plenty of others. So you can point at one of those, and then you can have models associated with those pools. This is their fancy graph that they use to sell this. I sort of understand it, but that like even the utilization of caches, like if you have hot spotting in your GPUs, it's going to make your inference performance suck. And so they want to make sure that if they can lower out any of those spikes, make it a better utilization of those very expensive resources, it's going to be a huge improvement to the point here where on the left, you're seeing like, yeah, it's kind of choppy, and the right's left choppy. The bottom shows how were those stacking up, right? So a lot of these end up just stacking up in a queue somewhere. You can see fairly sizable 20 plus, request waiting in queues. It wasn't allocated efficiently across the resources. Once they were able to get in there and really fine tune how these things were being routed, queue depth turned to zero, which that's what you love to see if means you're really making good use of those resources. And then, faster, right? So latency, of course, improves, like 4 seconds down to sub 2 second at least, so. Yeah, so I have some demos on this. Let's, before that, just step through a few things here. I want to show. So this is their page showing that same, right? So you have gateway routes. Routes can still go to service. You could have, if I had done this with more planning, I would have used a regional load balancer for that first demo, and I could have attached all this stuff. All it cares about is /chat and /chat completion. Oh, that's the spec. Anyways, that's their at least route spec. That's an open AI's chat and chat completion protocol where you can send queries for prompts and get back results. And so that is what this is entirely based on. The inference extension is you can put a bunch of models behind that. You can do more advanced routing, like inside the JSON object of the body sent to the load balancer has a model name. Wouldn't it be great if you could route on that model? You got to get all the way into the request. It's not a header, it's in the request. So they have something they call model aware routing, and the mechanism is body-based routing, where they literally say, somebody wrote, I believe, a Go program that inspects details coming from the load balancer that we'll talk about, and then takes that and just injects it as a header. Now I can use my HTTP route, right? And so it's your ability to expand the load balancer used to be Lua, or used to be, it's getting to the point now where you maybe can run WASM if you're really lucky. You could run some WASM extensions. But in this case, it's using, didn't open it, but something that we call service extensions. Which are actually still in preview for some. Here. Service extensions. So the reason why I feel slightly better about a lot of this being, so like we have it in preview for some of our load balancers. This is the one that we actually use for our inference gateways. And so route callouts, it is a feature that was inside Envoy called external proc. It will take information from the request, like the headers and the body and the stuff you care about, package it up in gRPC, send it off somewhere. That thing has a very specific way that it responds and says, hey, I want you to do this, 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 and this. It can do it as a route callout, or it can do it as a traffic callout. The plugins are the versions of like, I want this run inline. I want my WASM running in your load balancer. We do have that in some places, but not others. And so like finding ways of doing all of this, it is the future of this, just like Lua was how people were doing it currently. There will be large companies that like F5 may at some point be a policy engine on top of anyone's load balancer by just being able to use this kind of extensive framework, right? Super complicated how to solve, like, again, but it actually does work. And the way that we can see that is this VLM load balancer. Let's just step through a few of them, and then I probably won't do the actual demo. It's not great.
We're lagging behind.
Yeah, this laptop is. Oh, I probably dropped off the internet again. I probably should just join.
Yeah.
But what we're going to see is, so we're going to see the same gateway and the same HTTP route, and we'll see what looks like a fancy header, but that header got created by this body-based routing. And all of the things that it takes to kind of make that happen really aren't that bad. At least, I think. Oh, to get up, go down. Really frustrating. MacKay AI Inf Gateway. Yeah, we'll just poke through these a bit and then call it good. So this was my stepping through all of those tools to try to figure out how they work. They have gateways go to routes, routes go to pools, pools go to models. You can have multiple models associated with each pool, assuming that deployment has all the weights and everything it needs, the actual hardware to do it. And then it can do LoRa stuff, which is way over my head, but like literally taking models and then just augmenting their weights, is my understanding. Sometimes via cloud storage, I think that's what I heard. So I want to get that working. I wanted one of these like talking in pirate speak and the other. So here's setting up the cluster to do this entirely with HP basic routes. So if you gave a unique host name to each model, everything's great, right? Like you can just do host based routing. This is where in these files, you'll literally see an HP route for each of these, just pointed at a different inference deployment. So like that's pretty straightforward. Here. So this external one, so this is a Helm chart that installs that body-based routing. It literally currently is just a service running in the cluster, probably going to be a managed service in our version of this, but it literally is a gRPC endpoint that receives requests from, in-flight requests, takes header information and says, oh, I see a model in this body. I'm going to tell you to add it as a header. And it does so before your HTTP route gets processed. That's what a route callout does. A traffic callout does it at a different phase of the load balancer. But because we have that in there, we can now use not this manifest, but this BBR. This is what that would look like, right? So we gave it one host name, but we said, hey, if you see this exact header with this value, right? This is what it extracted and injected into a header space so that now our HP route can use it. The part that did the extracting isn't fully GA, but it's a pretty simple Go program doing gRPC stuff. If you're comfortable with those, you probably can be pretty comfortable with this.
To paraphrase what the service extensions are, that's middleware for Ingress that calls something else to do. It's a the Kubernetes API has these. It's a mutating webhook.
So
But it's instead of between
what it exactly is in our infrastructure is Envoy has external processing filters in its pipeline and has used them to great extent. So much so that this entire inference gateway is built around them. And I fully expect non-Envoy based load balancers will likely end up implementing that exact same mechanism of here's the protobuf. It's just got request. It looks like an HP request stuff, right? And then it sends it on its way. I can show you, and I'll show you after because I don't think most people care what that looks like as a Kubernetes resource. Because yes, we're programming it via Kubernetes, but what we're doing is we're creating this service route callout that actually lives on the load balancer, and that load balancer goes through its logic, hits a fork, and says, "Oh, I was told package stuff up, send it here, wait for response, and then continue on." And the only thing that accomplishes is literally extracting these words from the body and putting them into a header so that now I can just do a normal header route, which is kind of cool. Like it makes it, I had another problem later. I was like, wait, they could just do that exact same thing. Like I can't write the BBR for this, but like it would be conceptually, if you understand that process, you control the BBR and now the world's your oyster. You can literally almost make it do anything you want. And this is just two of them, right? So, or three of them. So it matches based off of that route. And now I can serve through that unified one endpoint and get the results. So this is just like, this is what those chat completion requests look like. It's just got a model, value, max tokens, and then a prompt. You send it off, you get a response. This is what people are getting $100 million evaluations for. Pay me now, please. EEP. So that has nothing to do with all of that fancy cache logic stuff we talked about. That is just like microservice composition of inference backends. So now to make it work at the next level, we actually have to use more Helm charts that create more resources. and do the like linking of stuff. And eventually this actually ends up having a service, which I haven't figured out the mechanism yet, but it's an endpoint picker that's even more in line, saying like, oh, I'm going to go out and scrape all those pods. You told me where the inference pools were. I will scrape their metrics directly. I will know what their cache utilization rates are at all times and use that information in my routing logic. And so I don't think it's inline. It's not another hop of a proxy. I think it's a traffic route extension, but I didn't get that far. And it's, you know, cool, great. Now we can have all the information running in a code base somewhere, making on the fly decisions to get the most efficient use of those resources. And that's basically what this is going to take. It doesn't require going out and building an entirely new load balancer. It just requires getting the information at the right time to make the right decisions. Some more HPA, so scaling based off of cache utilization. This is actually just using the external metrics that we're all used to. I think I have an HPA here, but it's not an interesting one. So that's what the metric looks like when it lands in cloud monitoring. Average KV cache utilization, and you can set some target value. I don't even know what these target values look like, if they're demoware or real, but 1% and 10, I guess is what or 1% is what I needed to make this scale. And I think that's basically it. Let's just see, because it's kind of neat to see how. So manifest inference pool. So what does that route callout look like, right? So it makes a service, it has a deployment, it's using streaming gRPC, which is kind of cool. GPC route extension. So this is the resource that says, hey, when requests on this gateway, you can have chains of things, because of course you can do more of these. There's some off stuff that literally, this is the one I was provided, was my XT comp. Supported events, so request headers or bodies or trailers in full duplex streaming mode, send here. And that's going to get all of the information on those requests and be able to do the extraction and injection. I can't find one of these for the EPP, which is weird to me, but I think it's because routing extension occurs at one place and they want to do at the very end, send here. And so that's, I think, the traffic extension. And then like health check policy. Yeah, I don't know how many people find that interesting. That is amazing that we went from what, like, I talked about this 3 years ago, not many people were using it then, still not people are using this. There are people using this for very expensive inferencing stacks and squeezing, you know, from there to there style latency out of it, and extremely happy to do so because it's saving them probably boatloads of money. And it is early days. They are hoping, I believe, both upstream and in the people that are really fighting for this, to get it towards a stable status as quickly as possible. I've been told that hopefully, you know, sometime this year. I believe them, but sometime this year easily can go into sometime early next year, especially when we have code freezes.
So in all of that, none of that, that's all more of a usage pattern of existing API specs than it is. There's no new API resources in that.
So there was inference model and inference pool, but those are shells on top of deployment, and it's like, I don't even actually know what the model does. The model just,
that was just the normal, the gateway.
and well within the outer custom API scope of what gateway was intending. They were always intending you could have other targets than services. You can have this parent ref and like the things you attach stuff to, you know, Gamma took it towards like, why don't we attach it to the service? We don't need a gateway. We'll just attach things to the service instead. So it was kind of all within the like broad vision, but you are correct. And the part that when I first saw it, I was like, oh, now I got to figure out this new load balancer and how it works. Like, oh, no. I've used this load balancer for many, many years. I know how it works. I've actually used service extensions for a few years. I know how they work. And so I just had to go in and figure out what exactly was it doing. It's like, oh yeah, that does make sense. Oh yeah, and if it is directly scraping all the endpoints, that's how you get the most up-to-date information. It's not waiting for the external metric feedback loop that the HPA has to do. It can get more real-time information. But I'll probably leave it there. If you find any of that interesting, I did extract like all of the manifest and stuff, so you can kind of dig through theirs. I have to reference it all the time.
I can't find anything about pricing. Or
Nine. So it doesn't cost anything because you're already paying for the data plane. You're paying for the load balancer just like you would at the normal rates that you would. You're paying for running the body-based route service thing that
so the managed Envoy is still running in your cluster.
No, so managed Envoy is just like our global load balancer. So it is a gateway class that represents a managed Envoy instance running within Google infrastructure, but you pay for it just like you would your Ingress rate.
So it's whatever, right? GFE, whatever. That is probably.
There's no add-on charge for any of this because we're making the money on the load balancer. And if this makes you use it more or use it instead of an L4, like there's definitely a premium on ALBs versus NLBs. So if it means one, you do hopefully have to do less work, get a better result out of it. But two, at the end of the day, if it means instead of people using L4s to Nginx running in cluster and we're getting compute costs off those pods, we're still getting some compute costs off of these gRPC services, but that's pittance compared to people that are cramming, thousands of requests per second, and then probably landing on GPUs, which are going to drive your entire bill anyways.
Yeah, the service extensions makes, none of the managed stuff has been possible because we've all used the external auth, right? That's the same thing.
Yeah, and you'll notice we talked about two of those. There are so many. And I don't even know what all of them are. It's, but I do know when it gets to super advanced stuff in load balancers, eventually we're going to talk to someone and they'll say, oh yeah, that's probably possible using something here. Edge is I think that's CDN. Don't know for sure. Definitely preview. Route plugin is your WASM in our load balancer. Call out is our load balancer gRPC calling streaming to your service and getting instructions from it. Authorization, all preview, don't think I've seen that yet, but that's probably more like if you want job stuff on a very particular manner. Super easy to do if you're in a cluster and can like or even Service Mesh can do this. This will probably be a mechanism used by Service Mesh to do fancy MTLS stuff or stuff like that in the future, but I really don't know.
Yeah, for us, it's just per request. Hey, allowed or not.
I know places that have done multiple round trips, meaning they'll do what they call a pre-flight. So they'll take the request, maybe they'll switch from get to head, so it's a little smaller, send it down the pipe, wait to see the response, and then in Varnish or whatever, capture details, and then send it down the actual pipe they wanted to go down in the first place. This is way better than some of that stuff. Right? But yeah, these are definitely pretty advanced. I would say there are still more advanced, like Varnish gives you way more control than even these do. But if it's a big enough use case that enough people want, the pipes are all there in the places that you usually need them to be. Especially when combined with that like header variable stuff. So TLS, one of the variables that you can get is a signature of the TLS handshake. Guess what's really good for like bot mitigation detection is like, how did they establish a TLS connection to me? We'll inject that into a header somewhere. You can either have your backend service make good use of that information, or maybe through an authorization call out or whatever it is, wherever you can make use of that information. Getting it available into HTTP routes means the more powerful gateway API is, the more powerful that information can be made use. Headers are kind of the variable of, that's how you pass variables around these kind of systems anyways. But yeah, if you haven't used these before, you're probably in a good spot to.
Yeah, I mean, we're doing the double, right? Quest allow.
I have walked customers through using this as part of Service Mesh. Service Mesh does make use of external proc as well. It is painful writing it in the Service Mesh world. I like this a lot better, especially when it's such a well-defined thing. But that body-based route extension, that's open source code. You could take that and say, oh, instead of this JSON format, it's going to look like this instead. And instead of this value, it's going to be this one. And boom, you're had someone write you very hopefully good code to be able to manage it. It is being run as a single pod right now. So like at some point, probably need to make it a more highly available version. But it will probably end up being something we just run as part of that inference gateway. It may at that point have money, but everything I've heard is like, this is so cheap for us to run and would help drive so much business that it's probably gonna stay in the same price.
Do you know if this is, like, we're using Contour, and I have an annotation on the HTTP proxy that does a neg that like bypasses Q proxy. Is this doing any of that magic?
So the TLS route and TCP route is where you can do that. TLS route is just, I'm going to, as part of SNI handshake, or as part of TLS handshake, inspect an SNI value and then not touch the packets. I'll just take that value and say, oh, it's host header matching one step earlier when doing the handshake. TCP route is just blindly like, I'm going to get packets here and I'm going to send them there and I'm not going to touch or do anything on them. Our implementation doesn't have it yet. Envoy definitely does. Envoy Gateway has all of those. So if you want a TLS pass through, you could do that through those. And it's standardized. We'll get there eventually, but we have so much on it. They've been marching towards this destination instead of backfilling that. And the service type load balancer usually works. Cool.
Any other questions? Please.
In your experience, how would this compares in terms of like monitoring, logging and telemetry with traditional Ingress? When everything goes down, how different is to bring it back up?
So Gateway API is just a means to programming the thing doing the actual work. I will say observability is part of the inference gateway mantra, but in that sense, it's kind of just like our dashboards. It's like we're going to standardize on VLM and Triton and the important metrics that come out of those, and then present them in dashboards. For normal ingress and gateway stuff, like it's still whatever metrics your actual load balancer is exposing. So the same metrics that you would have had using Google APIs, using Ingress APIs, or using gateway APIs, it doesn't change those. On the inference side, it does, because that endpoint picker is the thing in the middle of the kitchen doing all the assignments, and it exposes metrics in a more standardized way so that you could potentially even do swaps of like your inference gateway, your inference deployment server. But it's not there yet. Like, I think now they just have a Helm chart with two different, like, hey, on this one, we'll care about this, on this one, we'll care about that, and hope that they match.
Thank you.
So if you're using Contour or Envoy Gateway, is the primary pitch that this is managed? Like what's the main motivator for someone choosing?
You won't have to learn it again, right? So like, you may have heard over here, it's like, wait, that's all this, like, you have to learn that every time of how do you do the splitting? How do you do the header adding? How do you do all this? Hopefully the idea is that if it's a mature implementation, they'll just do it the way that the core API says to do it. They are all on different levels of implementation right now. So you can see some of these, like the cloud providers are pretty much GA because it's in their interest to really make this work well. Envoy Gateway, it's basically the team that just said, everyone else is using our load balancer, why don't we build a version of it that doesn't have strings attached? So that's kind of nice. Glue, that's Solo's gateway. This is also K Gateway. If you heard, they donated a good chunk of that to open source. AJ Proxy has two, apparently. I don't know what those are, but one's alpha, one's GA. HashiCorp has one, Istio has one. They say GA, that's true, but also quasi not. Kong, Kuma, the contours is there. It says GA. What they support in terms of their routes. So like you saw, we used almost all of these backend TLS policy. We didn't. Not all of them have that, right? So like we don't have this in our gateways. We don't have this in our gateways. We don't have this even, but gRPC is just a wrapper around HTTP. So yes, it makes it slightly nicer, but I can also show you an HTTP route that can do just about anything that a gRPC route can do. So it's kind of that first evaluation of like, well, what features do they have? I think Contour is one of the, they see it, they see the light, they understand that this is the direction that's probably in their interest to go. Also, how quickly they update, but not only how quickly they update, but how quickly they keep their docs updated. Like we have problems with this, and I've definitely landed on a ton that are just like, oh yeah, 1.0. I'm like, it's 2 years ago. Are you still on 1.0 or do you have 1.2 or 1.3 or are you working on 1.4? What's the lag? That kind of stuff. Long term, it'll just become boring and stable. But even that for core routing is probably big.
Right, I'm just curious, like, is there a pitch for why the GKE gateway is?
I mean, it's hard for them to maintain that. So one of the reasons, frankly, why Google invested heavily in Envoy is like TLS 1.3. We had to implement that in our proprietary load balancer. I wouldn't wish that on my worst enemy. Like that sounds miserable and terrible. Guess what had it from almost day one? Envoy. So many people are working on top of Envoy, you get to kind of commoditize that. And it's the same with a lot of things of the spec of like, well, you have to invent the way to program the load balancer, or you just use the way that everyone's kind of standardizing on it. So it doesn't, like performance wise, I don't know that it actually has major differences, because at the end of the day, it's not a data plane thing. It's a control plane. How do you use this thing? And then how do you make it easier to switch? And if you give me two options, one of which I know is a lock-in, I didn't show, but like Nginx says they're on their last version of Nginx Ingress. The maintainers are exiting and saying, we're going to pursue Gateway API pastures. It is not going to disappear anytime soon, but you will not find future iterations of Nginx Ingress implementing advanced things. You'll likely find F5 implementing them as part of Nginx Plus, or Apache implementing it as part of their API gateway, or various things like that. And so having to pick between those, if I can pick one that says, like, probably make a different choice in 6 months and still make use of a lot of my investment, I'd definitely probably hit that way.
Any questions online? I know we're talking about two different areas, but Cloudflare kind of, they're coming from a different way, in a different direction, but I could see them kind of.
Yeah, it's always layers. At some point, you are very likely to have 2, 3, 5, 7 proxies in your ingress path, and the external one being a CDN like a Cloudflare. Or if you were doing home lab stuff, like it may just be that they're the easiest way to bridge the firewall gap, stuff like that. I don't know if they have a gateway API. It's a fun thing to search for. Every time you're like, I want to program this thing, wonder if they're using gateway API. Long term, I would expect there's a very valid reason they might do so if they're running in the Kubernetes world. If you're not in the Kubernetes world, especially when they're doing a whole bunch of other stuff, they have a great way of programming their systems already. So it may or may not make a ton of sense.
The only thing that needs to change between using gateway API definitions is the gateway class.
Gateway class, and then things that aren't core. So health checks.
Extra nonsense.
Yeah. They definitely aren't as nonsensical when you're like, oh, no, health checks are very important. I want to make sure I use health checks at this path with this, an HPE health check versus an HPS health check, gRPC health check. Those exist now. Well, a lot of load balancers, you can just say, I just want a health check. There's literally a protobuf for health on gRPC. And so being able to specify that, what will likely happen, and from what I've heard on like MTLS fronts, is like people that are really interested in it are probably going to pave their own path with custom resources. And then if it's enough people headed there, they might say like, hey, let's see if we can get this into the core instead. I showed you all the stuff that was really easy. I literally went through that slide and just picked everything I could off that slide that I knew was core. But it's definitely easier than same with storage classes, right? Like you have to make changes on storage class, but you don't usually think about it too much. And that's what they're really hoping for, at least the core routing stuff.
It's typically the onus of the storage class implementer.
Yeah. Storage is a little simpler too, because it's like size and throughput for IOPS. Like there's 3 or 4 variables there. There's a lot more at play here. There is a project called Nginx 2 Gateway that had a pretty good amount of traction, because there's a ton of people with existing Ingress resources. And so you can run your manifest through that and it'll spit something out. How well that does, I actually haven't spent a ton of time on. But if a bunch of people are like, oh, this is mechanical transformation, there are projects trying to help mechanically transform that. And I'm sure the LLMs will do it well too.
All right. Get this posted and also slides. Do you want to?
They're up there already. I posted them in the Slack channel and they're.
Have.
Yep.
Thanks very much.
Button's still there.
Can I eject people?